Today's lesson is on writing ionic formulas. But before we write them, let's take a look at some. You've seen some in the chem lab on bottles. You've also seen some on the internet. So let's take a closer look at the formulas themselves. So here's a really simple formula. There's a K and the BR. And you might notice that there's not a 1. So it doesn't go K1, BR1, which is what it implies when there's no number. It implies there's one of each, but we still don't write K1BR. So that's a simple formula. Let's take a look at this formula. Now we do have a number, and it's the number 2. So I have Li, which you should remember is lithium, 2, and an O for oxygen. So it has 2 lithium ions and an oxide ion. So let's take a look at a little bit more complicated one. Let's take a look at this one here. We've got some subscripts. We have a 3, and that means there's 3 barium ions. And we have a 2 here, but we also have parentheses. So what does that mean? Well, that's just like in math. The 2 outside of the parentheses means the 2 goes with everything inside that parentheses. So what is inside the parentheses? A PO4 ion. And you should recognize that as the phosphate ion. So this formula here means there's 3 barium ions and 2 phosphate ions. All right? So I think you got the idea. Let's go on and try to write some ourselves. So let's write some, and we're going to start with some simple ones. So get out a piece of paper and follow along with me. If you need to, you can pause the video, but practice with me as we go along. So pause the video and join me in a second. All right, welcome back. So we're going to write these formulas. These are simple formulas. So I'm going to write the formula for sodium chloride. So the first thing I'm going to do is write down the ion. So the sodium ion is Na, and it has a plus charge. The chloride ion is Cl, and it has a minus charge. And how did they get to be charged in the first place? Well, chloride had to gain an electron and sodium had to lose an electron. Well, that's a perfect match. Chloride wants to gain one, sodium wants to lose one. Why don't they just get together? One of sodium will match up to one of chloride, and we simply put them together. So the name of this formula is sodium chloride, and it's written as NaCl, which means I take 1 sodium and 1 chloride together. And their charges equal out. We're trying to equal these charges. And also the losers equal the gainers. Notice there's no charges in the upper corners anymore because the total charge on this equals 0. You haven't written a formula properly if the total charges are not equal to 0. Why is that? Well, you have to have the electrons come from one atom and go to another atom. So they have to always equal out. The gainers have to equal the losers. So we're going to remember that while we write these formulas. So let's try one a little bit more difficult. So let's go down to iron 2, which you should remember is Fe 2 plus. And now oxide, that's O 2 minus. So how did they gain or lose electrons? Well, they swapped them. So iron wants to lose 2 electrons, oxygen wants to gain 2 electrons. Well, once again, they're a perfect match. Oxygen can take the electrons from iron, and so we need 1 iron and 1 oxygen. And there we have our formula. And if we added up the charges, 1 plus 2 and 1, 2 minus, equals a total of 0 total charge for this. So we're going great. What about aluminum phosphide? Aluminum has a 3 plus charge because it wants to lose 3 electrons. Phosphide has a 3 minus charge because it will gain 3 electrons. You might notice a pattern. Say, Miss Backus, oh, this is easy. Aluminum wants to lose 3, phosphorus wants to gain 3. All I need is 1 aluminum to react with 1 phosphorus atom, and we're good. So the formula for this is ALP. And does that add up to be 0? 1 with 3 plus and 1 with 3 minus? Sure, that adds up to be 0. So, hope you got that. That was really simple. Let's try ones that are a little bit more difficult. So let's try some that are a little bit harder. So let's try to write the formula for sodium oxide. Well, sodium, as we know, is Na, and it has a positive charge. Oxide is O, but it has a 2 minus charge, which means oxygen will gain 2 electrons, but sodium only loses 1. So I can't just put them together, 1 sodium and 1 oxygen, because sodium's not going to lose a second electron. We talked about that. Once it loses 1 electron, its atomic size goes way down because it lost an energy level. The effective nuclear charge goes way up. So it's not going to lose that second electron. So I can't put 1 sodium with 2 oxygens. So how am I going to do that? Well, if the sodium will lose 1 and oxygen wants to gain 2, what happens if I take 2 sodiums? This sodium will lose 1, this sodium will lose 1, and where do they lose them to? They lose them to this oxygen, which wants to gain 2. So to make a proper formula for sodium and oxide, one where the gainers equals the losers and one where it is neutral, I need to take 2 sodiums. And notice I write that as a subscript. It's not a superscript, it is subscript. And 2 sodiums for every 1 oxygen. And remember, I don't write 1 here, that's implied. I take 2 sodiums for 1 oxygen. So I have 2 that have a +1 charge and 1 that has a -2 charge. And yes, that is what we call neutral. The total charge is 0. So notice there is nothing written here. There is nothing written here. Okay? Because the whole thing is neutral. The whole thing has a 0 charge. Okay? So I need 2 sodiums for every 1 oxygen. All right, let's try another one. Aluminum has a 3 plus charge. Chloride has a -1 charge, which we just put the minus by. How are they going to get together so that the losers equal the gainers? Well, aluminum wants to lose 3, but they can't just toss them into the air. Chloride wants to gain only 1, so chloride's not going to gain 2 or 3, it's only going to gain 1. So how can I make this so that together the losers equal the gainers, and together it's going to be neutral, has a net charge of 0? Well, I think if you think about this a while, what if I take 3 chlorides? So if I have 3 chlorides and 1 aluminum, I have a total positive charge of +3 and a total negative charge of -3. That would give me a neutral compound. I would have 3 being lost and 3 being gained. And so that's neutral. So I write the formula AlOCl, sorry, not O, Cl3, aluminum chloride. And together, that gives me a neutral compound. So I'm good. And you don't have to write the equals 0. I'm just trying to remind you that together it is a neutral compound, and that's why we don't have any charges in the corner. Okay? So let's try one more. Iron 2 phosphide. So iron is Fe2+, and phosphide is P3-. And you might say, oh no, that looks a little more difficult. It was easy before, but that's a little more complicated. Well, let's think about this. It's our math analogy here. We have to have the losers equal the gainers, so it has to be neutral. So if you think about it this way, which we could have thought about that before with the plus and the minus from chloride, okay, what do both the number 2 and the number 3 go into? So what's the lowest common multiple of 2 and 3? So give you a second, think about that. What do both the number 2 go into and the number 3 go into? Well, they both go into the number, did you say it? 6. They both can go into 6. So I can have 6 losers and 6 gainers, and that will neutralize each other. So how do I get 6 losers? Well, I have iron with the 2 plus. So how do I get 6 losers? Well, they both go into the number 6. So what times 2 gives me 6? Well, I need 3 of them. So iron, iron. I need 3 irons. And what multiplies by 3 to give me 6? That's the number 2. So I need 3 irons and 2 phosphides to give me a total of 6 positive or 6 losers and 6 gainers. Now that will be neutral. And so now I can write the formula. So I need 3 irons and 2 phosphides. 3 of them lose 2, 2 of them gain 3. Together they lose and gain 6. And so it is, yes, a neutral compound. All right. So let's talk about ions that are polyatomic, and some of them will need parentheses, and polyatomic means many atoms. So polyatomic ions are the ones with more than one atom attached to it to make a single ion. And so let's take a look at these. Calcium is 2 plus, and that's not a polyatomic ion, that is just the element calcium. But sulfate has both sulfur and oxygen together, so it is a polyatomic ion. Calcium is 2 plus, sulfate as this entire unit is 2 minus. Well, calcium wants to lose 2, sulfate wants to gain 2, so I just need one of each. And there I have my formula for calcium sulfate. Now notice this 4 here was part of the sulfate unit. So SO4 is one single unit. So I have 1 calcium and 1 sulfate. So not too difficult, right? Pretty easy. Let's try the next one. I have aluminum sulfate, Al3 plus, and sulfate we just did right there is polyatomic, SO4 2 minus. Oh, this reminds me of the problem we just recently did on the previous slide. I have something that wants to lose 3 and something that wants to gain 2. How do I get that to be neutral? Well, I need to look at the lowest common multiple, which is 6. So how do I get to lose 6? Well, I need 2 aluminums. 2 aluminums will be a total of positive 6 charge. How do I get a negative 6? I need to take 3 sulfates. And there we have, oops, the formula. No, that's not right. I want to take 3 sulfates, but it looks like I took 43 oxygens. I want to take 3 SO4 groups. So how do I do that? Just like in math, I want the 3 to go for everything inside the parentheses. So there is our formula for aluminum sulfate. So let's try our last one. So we have aluminum again, which by now, of course, you know is 3 plus, and hydroxide, which is OH with a -1 charge. How do I get those to neutralize each other? Well, what do both 3 and the number 1 go into? They both go into 3. So if I could have 3 losers and 3 gainers, that works. So I have aluminum. I just need 1 aluminum, but I need 3 hydroxides. So now I take 3 hydroxides and I'm done. But oops, that's not right either, because I didn't really take 3 hydroxides. I took 3 hydrogens and 1 oxygen and 1 aluminum. So how do I take 3 hydroxides? I again need a parentheses. Anytime I have a polyatomic ion that I take more than one of, you need those parentheses. So there we have it. Now it's time for you to try them on your own. Good luck and do well.